So it's like on larger scales, like the human norm project use computer technology to process vast amount of data and also lend insights into how our biological information processing functions. So here are some other examples of computational thinking as well that can help us. So they are suggested by computer scientists. So the first thing is that you look at the problem and assess how difficult it is. Second thing is that you use recursion to apply a simple solution repeatedly. Recursion is basically like we are going to look into that detail. So recursion is basically a process where you work with anything repeatedly again and again. So if you are doing anything repeatedly, it's like the concept of recursion. So recursion is basically the practice or like the phrase that is used uh to return something or to determine the succession of elements. So you can use this to apply a simple solution repeatedly. You can reformulate, you can reform a problem into something familiar that we know how to use that. You can also model a problem so that we can create a program that can be run on the computer. So we can actually model a program so that we can create a program that can be run on computer as well. We can also look at a proposed solution and assess it for its elegance and efficiency as well. Again, with the help of the computational thinking, and we can build in process to our solutions that basically limit the danger and recover from errors. We can scale our solutions as well. Do you have any problem in these points?
No.
It's like when we are actually looking at solving a problem with the help of computational thinking, we have to decide first what part of the problem, if any, are best suited for the computer solution. So this links back to the old age problem as well, where we where the question that predates modern computer, whether a particular problem is computable or not. So like there is an algorithm that will always give the correct output for a valid input. So it has been demonstrated that in some cases the question is undecidable. Like you are always not sure that if the algorithm is going to give the correct output for a valid input as well. So you have to make your judgments and you have to use some practical part. So we have to decide which part of a problem are best suited to human resolution. So computational thinking basically it encourages us. So you can actually select with this ability that what the computers are best at and what the humans are best at. And when we uses our strengths all together, this is what that makes the accurate solutions for us to work for us to work with us. So do you have any confusion?
No.
Now there are actually some steps that we need to look forward when we are working with computational thinking. Discuss with you now the number of stages involved in computational thinking. So the number of stages involved is like the first thing what you need to do when it comes to your computational thinking is you need to understand the problem. It's like there can be certain things. So you need to understand how do we know that we understand the problem sufficiently. So this does not actually relates to the solution, but this relates to like how we are trying to solve the problem. The second thing that we need to take care of is that we need to formulate the problem. Formulating the problem means like in this stage, we need to produce a concise representation of the problem. Let me write it here for you. So in the first part, it's like you need to understand here that how do we know that we uh, understand the problem. This means that you need to understand this at first. So, or at least you need to show that you are trying to solve by understanding it first. This is the first stage. Formulating the problem in this part, we need to produce a concise representation of problem because you are formulating it means you are formally working with it. So here you are going to work with abstraction. So this will involve abstraction, and I'm going to discuss with you later on that what is abstraction. Like at this part, some mathematical notations can also be included, but we are going to focus on abstraction first, which is this. I mean, later on. After that, the third stage I have right here is for designing an algorithm. So you can say that once we have a clear representation of the problem, once we have clear